Here we are for the Semester 2 IA Review Solutions. So hopefully you've given these questions a try and you're just here to check your work. Also remember to check out the Unit 3 review, as that will be, as I said earlier, very, very helpful. So here you can use the quadratic formula. You can factor. For this first situation here, we're going to set the equation equal to, or this expression equal to 0, and then what we can do is we can actually factor this quadratic, so it will be x plus 3 and x plus 1, and when that equals 0, well, what we know is that one of these has to be 0. So from this we know either x will be equal to -3 or x will be equal to -1, and those are the solutions that will make that expression equivalent to 0. For the second one here, we can try and factor this, and what we'll realize is we're going to have to use the quadratic formula, and so I'll go ahead and do that, and I'll show you the steps and you can kind of go through it. Alright, so here I've used the quadratic formula to solve, and this is going to be a complex solution. So here are the two solutions. -1/4 plus or minus 7.5 over 4 times I, and so those are the two values that will make this equation true. How many distinct roots can a fourth degree polynomial have? Well, if you think about a fourth degree polynomial, it will have 4 linear terms, because that's how we'll get x to the fourth. And so you couldn't have 3, because if you had 3, well then you would have a third degree polynomial, and you can't have 5, because if you had 5, you'd have a fifth degree polynomial. So it can have at most 4 distinct ones. Notice that it could have, so let's say you had x minus 2, and perhaps you had 2 of them, so it's x minus 2 squared, and maybe x plus 3 squared. And so what this really is, well, there's 4 roots, but 2 of them are the same. And so we know that a fourth degree polynomial will always have 4 linear factors, but it could be the case that a couple of them are the same, like there are here, but at most it can have 4 distinct or unique roots. The binomial theorem here, remember the binomial theorem is for any binomial a plus b to the n. We expand it by taking the sum as k goes from 0 to n of n choose k, a to the n minus k, b to the k. And so when I go through this, I'll just write the first couple of terms out. I have 5 choose 0, 2x to the 5th, and 1 to the 0, and then the next term, 5 choose 1, 2x to the 4th, and 1 to the 1st, and all the way through until I get to the last term, which is going to be 5 choose 5, 2x to the 0, 1 to the 5th. And if I were to, when I keep going, I'm going to simplify by actually deciding, what is the number 5 choose 0, 5 choose 1. Here I can, take the 1 as well and multiply it through. So I'll do a couple here. 5 choose 0 is 1, and 2 to the 5th power, right? So 2x to the 5th is 2 to the 5th times x to the 5th, and 2 to the 5th, so I'll just let you know. So this is 1. 2 to the 5th power is 32. So what I have is 32x to the 5th plus 5 choose 1 is 5. 2 to the 4th is 16, and 1 to the 1st is 1. So I have 5 times 16. 5 times 10 is 50. 5 times 6 is 30. So that's 80x to the 4th all the way through. And the last one, 5 choose 5, is 1. 2x to the 0 is also 1. 1 to the 5th is 1. So plus 1. And that would be my final answer. And I will remind you to make sure that you review Unit 3 and 4 using the following situations here. So review solutions, tests, and quizzes, and of course Unit 4 videos and questions.